All right, today is the big day. We're cutting tubes for the roll cage. In the previous video, if you didn't see that, I showed you how to get all of the dimensions into this car that we're calling Sharky, which will be racing at the 24 Hours of Lemon. So go back and watch that if you want to figure out how we design the roll cage. Today is all about how we get back into the computer and turn that CAD program into a computer-aided manufacturing program, something that we can create G-code, and we're going to go ahead and cut all of those tubes. Realize I'm going to be cutting today using the Dragon A250. You're going to be totally impressed by this machine. But if you can't afford one of those for some reason, if you're a 24 Hours of Lemons guy, yeah, they're expensive, so I get it. But you can do everything I'm doing today using an angle grinder and a couple pieces of paper that you'll print off of a printer. I will provide links in the description below of videos that I made previously to show you exactly how to do all those things. But first, let's go ahead and hop on the computer. We'll take a look at the design, and then we'll start mapping out how we're going to do the cuts and kind of come up with a game plan on how we're going to weld this thing together. All right, so if you watched the last video, this is where we left off. We have a full roll cage that we've designed now. Now we got to figure out how we're going to cut it. As far as the CAD part of this thing, I'm going to show you some of the pitfalls and some of the things I've learned along the way. And then the physical, actually the cam or the manufacturing part of this thing, there's two options. We're using the Dragon A250. You're going to be totally impressed by that machine, but you can also cut all these things, every single one of these tubes, using an angle grinder. And I built an entire race truck using an angle grinder. It took a while, but I guess you could probably do this whole thing in about a week or something like that. And then when I use the Dragon A250, it's going to take about 20 minutes. So here we go. So here's kind of my philosophy when I try to figure out how I'm going to cut these things out, and eventually how I'm going to go ahead and weld them together also is, when I build roll cages, I kind of almost think of these as like bulkheads. Like this B pillar right here, this is one flat piece. And what I would like to do is weld this whole thing on my fabrication table as opposed to in the car if I can. So I'm going to, as I kind of start mapping out how these pieces are going to be cut, that's what I'm thinking is I want to put this whole thing in there and I want to have it completely finished welded on my table to where you're in the most comfortable position. I think also for me, I make my best welds while it's just sitting there in whatever orientation I want it to be in, because once it gets into the car and then now you're doing some kind of crazy gymnastics to get every weld and weld 360 degrees around. And I'm TIG welding. MIG welding might be a little bit easier if you're good at that. I'm not. I'm a little bit better at TIG welding, so that's what I will be doing. So with that, let's talk about how we're going to cut it. So you go to the BendTech software over here, and we go over to the cutting tab, and then I'm going to just say a new cut. And as far as how do you make sure you get all of them, you just kind of got to give yourself like a rule. Like I'm always going to go either from the top to the bottom or the bottom to the top. I usually go bottom to the top, but since we're doing something different on the bottom, I'm going to go from the top down. All right, so let's get started with cutting this, kind of, trying to stick with those rules as best we can. I'm going to say a new cut. I'm going to grab this tube. That's a tube I want to cut. And then I'm going to tell it what tube I want it to cut in relation to. In this case, it's going to be the top of the B pillar. Now realize that these tubes will eventually be there also, but this tube is the first one there. I say complete cut, and then now you can kind of see how that is only coped to that tube. And then I'm going to go ahead and make a new cut, and I'm going to cut the other side. I'm going to cut it in relation to that tube, complete that, and then there. Now that tube is all accounted for, and you can kind of see where it has the cuts there on the side. Now we're going to go with these tubes right here that make up that seat belt, the back of the back of the seat there. I'm going to say new cut. We'll do this tube. It's only going to be cut in relation to that one. I'm going to complete that one, and then. It's always a good idea to kind of QC that the number of cuts you expect to have equal kind of what you've done. So each tube should have 2 cuts for cutting on both. All right, so here's the next case is we're going to now cut these the A pillar tubes here. They're going to come all the way in there. So I'm going to say a new cut. And this is something you got to think about whenever you're making these cuts is what order are they going in? In this case, I want to cut this one right here. Now I know that when I put that tube in there, that this tube will already be there. So I've got to cut it in relation to that tube. I've also got to cut it in relation to that tube. And this down tube right here probably will not yet be there. I'll probably put that one in there first. And as I complete that cut, you can kind of see where if I don't take an account that other tube that's already going to be there, then that piece, will still be there, and I have to go in with an angle grinder, cut that out. So it's a good idea thinking about what will be there before you make the cut. All right, here's another thing to look at is these back tubes here. I'm going to say new cut. I'm going to go ahead and cut this one. And now, again, we don't want to cut in relation to the B pillar. We want to cut it in relation to that cross tube that goes in there. But what about this tube over here that we know will be there before it gets there? But I don't really think it comes over there and touches that tube, but you just never know. And so I always select more things than I necessarily have to. So as I complete that cut, I can kind of come in there and inspect it. And sure enough, it does not appear as if it comes over and touches that tube, but sometimes it will, and you won't realize it until you try to start fitting it up later on. All right, and then finally, I've got all the tubes accounted for, but what I have left are these 6 tubes, or the 6 ends down here, where they're basically landing on a flat surface, which is level with the car in the way that I oriented everything. These pieces should be like a 0 plane. And so what I did is I selected this cutting plane feature, and you kind of see the cutting plane is already on there. And as I say, I want to do a new cut, and let's say I want to do this tube right here, and if I select the extend to plane button, then what it will do is extend it to whatever this plane is right here. All right, so I've been playing with this thing for a little bit, and this is kind of what I came up with. The way that I'm able to make this usable for me is I kind of change the dimensions of it to kind of pull the points away such that you can manipulate them without it. And then what I'm going to do is I'm going to project this thing from the left. And it looks like a line, but if I zoom way in, and you can kind of see as I get closer and closer, I want this thing to be as accurate as I can get it. I'm going to go ahead and move this thing until it creates a line. So I've basically normalized that plane with the car. I think there might be another way to do it. I just don't know how to do it, where I just say make this thing 90 degrees from that point or whatever, make it flat. And then I'm going to go ahead and change projection to where I'm looking from the front, and I'm going to do the same thing. I'm going to go ahead and totally zoom in, and you can kind of see that they're not completely lined up. I'm going to make that a nice flat line. And then the last part of it, just making sure that the center of that plane is over top of at least one of those points. As far as elevation goes, that's probably the most important. If I project it from the left again, I can zoom way in, really far in. Now I'm down in really small measurements, and now it's on there. So that is my plane. And the only reason I'm doing this is because what I want to do is I want to make a new cut. And then I select it over here, extend to plane. And so now as I click on this, it isn't even asking me to select anything else. It is now cutting that thing in relation to that plane. I'm going to say complete. And now I'm going to do that on all those. And you can kind of really see where it makes a difference over here on this back one. And I say complete, you can kind of see the cutting that it's going to do there for that one. So if I didn't do that, it's going to take a lot of other gymnastics to kind of make this happen, where I have to make fake floors or tubes or cut something to cut in relation to. So this is a nice feature to have. It does save some time, but there's probably a way to make this work a little bit better for me. So. All right, then now that I have the plane selected on that rear area there, at the same elevation, now I can go ahead and complete those cuts also. So new cut, and complete, and then new cut, and complete. So now that we have all the cuts in there, now is an exercise to make sure you have them all exactly how you want. So I'm going to take a couple minutes here. I'm going to go through every single cut. I'm making sure that I didn't leave material on or didn't take too much material off. So just QC this, because once you cut it, you can't uncut it. So I'll go through every single tube. One easy way is just first to make sure that there are 2 cuts for each individual tube representing each end. And then I'll click through each part and I'll say, okay, is this the cut that I expect to have on there? You can zoom in on each part on each end and go, yep, all right, there you go. So I'm gonna go through every single one. Okay, so from this part, we have accounted for all of the cuts and we're ready to go either to a Dragon A250 or check out the 2 videos in the description, one telling you how to make a cut on a straight tube and one telling you how to make a cut on a tube that has a bend in it and maybe 2 copes on the end. Those are 2 different techniques and 2 different videos I've made for this that you can watch. And I made those a while ago, but they're still valid. And you can kind of see that when you go in there and you look at the details of the cuts, this is kind of what's going to give you if you're going to manually cut that. This is going to be a piece of paper you're going to print out, and those videos show you exactly how to put those on the tubes, how to mark the tubes, and the ways that I was using an angle grinder to cut those. But what we're going to do is use the Dragon A250. Things I want to like to do if I'm going to cut on the Dragon is change the names of all the things. Because if I have the word straight 1, it's actually going to use a pen on each tube. It's going to write the full word straight. And I know it's a straight tube. So I'm going to go in here and I'm going to just go ahead and change the name just to the tube number. So now the parts are all renamed. One of the weird rules is you got to be in some other window other than parts. And then you go over to transfer and send this thing over to Dragon Cam. And this is gonna be the really cool part. Once this window pops up, here's all our parts over here. We're gonna make a new nest. And then I'm gonna tell it how many tubes I have. In this case, I've got 4 20-foot tubes, which are 240 inches. And then I click on this auto nest, and then now it puts all those parts into a nest. And it tells me all I need is 3 of my 4 tubes, so I can put one of those away. And now what I'm gonna do is I'm gonna clean all these tubes and get ready to send it to the machine. To do that, I just hit the Run Project button. It's gonna open up all of its software. It runs the CAD. The first thing I have to do is home the machine, get the water system set up, and I'm ready to start cutting tubes. Here is where we're at right now. We got all the tubes cut out, and what we've been doing is we've been running them through the surface conditioning tool to get the end shiny, because we will be TIG welding these. We also kind of clean up the inside with a die grinder. And then I had a little concern about the angles. I actually kind of bent 2 tubes already to see how they would do. They want one at 25, one at 23 degrees. But I kind of decided, you know what, I better go check and make sure I'm getting the right degrees on there. So I checked over here on the computer, and here's that tube that needs to go to 23 degrees. And usually it writes the spring back on there. So usually what you should see on the tube is 26, but it wrote 23. It wanted the resulting angle to be 23, So you bend it to 26, it springs back to 23. Well, it didn't do that. So I'm not sure why. I gotta go back and check and see why it didn't put the spring back angle on there, which means I gotta go put those two tubes back in there and bend them another couple of degrees. I'll bend them to 26. It should spring back to about 23 degrees. And every time after I do a bend, I do go put it on my bench and I measure them up, and I'll show you how I do that after this next tube I'm gonna bend, just to make sure that's going right. So who knows why it's doing that. So we're bending this tube. This is the B pillar, and this is kind of the biggest tube, the most expensive tube. So those other ones, if they were wrong, it's not that big a deal. They could even probably be at 22 degrees, 3 degrees off, and that's fine. This one cannot. This one has to be more accurate. So let me show you some of my things I'm thinking about when I'm setting this thing. First of all, you see I'm putting to use some of these scissor jack things. So what I did is I got this Irwin level out, and I want to make sure that my die is level indexed to everything else. So I leveled it this way, and maybe you would call it the x-axis, and then I leveled it this way, and then using those scissor jacks I did that. And that gets the whole system level. And then I kind of came over here, and now I'm going to level the tube as it's feeding into the machine. So that's level also, and that's important because you can imagine if it's canting up or down, it's going to change the angle. So it's got to feed in there level, and that's pretty important. And then I'm going to use this other trick here. I have an angle cube. I 3D printed this piece off here. I know somebody else makes a tool like this, but I 3D printed this. I clip it on there. I'm going to zero it out, and since both bends here should be in plane with each other, I'm going to I'll zero it, make the first bend, and then I will slide the tube up to make the second bend. I'll make sure it's zero again as I make that second bend, just because any degrees that you have in error when you're doing bends, it just compounds. I've mentioned this before, there's a rule that we as pilots know, and it's called the 60-to-1 rule. So let's say you're a pilot and you're flying 60 miles to a point, and you're 1 degree off. Well, when you get that 60 miles, you're also going to be 1 mile off. So if you've got a 60-inch tube and you're 1 degree off after bending it, the end of that tube is going to be 1 inch off from where you expect it to be. So that's not such a big deal. For an 1.5 inch tube, you can probably bend that and manipulate it to get in a position. But if you get some really thick stuff like 2-inch tube, you're really going to have to put some hydraulic force on there to get that tube into place. So we're going to try to minimize that error as much as we can, especially on these long bends. Let's go ahead and make these two bends. When I'm building cages, I always think that getting the dimensions right on bending is like one of the hardest things to do. We were shooting, you see, for 84 degrees. I got these two pieces of angle aluminum along here. We get 83.3 degrees is what we hit. So that's pretty close, 0.7 degrees off. I wish it was a little bit closer. Let me show you the slight error that we got from the bender. So this is a result of that 60-to-1 rule we were kind of talking about, where we have, there's a bend here, a bend here. This is a long run, and I think we were maybe about a 0.5 degree off, because you see at the end here, that's how far off we are, and that does seem like a lot. What we'll end up doing is clamping this thing flat and then putting the rest of the tubes in here. All right, as we're getting ready to weld this, we'll be welding today with a TIG welder. This is my Miller Dynasty 200. Now realize I did weld the last vehicle with the Vulcan Pro TIG, I think it's a 205, and it did amazing. So you don't need to have a really expensive TIG welder to do this. You just kind of need to get yourself a little bit of experience. That being said, I keep telling people I'm not a professional welder, I'm an amateur. This is just how I do it. I will probably set this thing up. I usually shoot for about 10 CFM on the regulator, the flow. This is a 0.125. I'll be probably welding at about 145 amps, throttling the pedal to kind of control the heat that's going into the material. Everything's cleaned up. I kind of got the stub. I got a gas lens on this thing. It's stubby, and it doesn't have to be, except for the fact that all of my tungstens look like little nubs now. I've got to get some new tungstens because I've ground them down so many times. It's time to get some more. Anyway, though, everything's ready to go. We'll start tacking this thing up, and the plan will be to get some tacks on this side so it holds itself together, flip it over, and then do some more finish welding, and then flip it over and then finish weld the other side. And then I'll hopefully keep it from warping and control some of the heat that's going into the whole part. I've gone around, and I guess you would kind of call this hard tacked. It's, you know, bigger than normal tacks that are on there, but it's not the full 360 around the tubes. I'll get that in a second here. But what you can see now is that, you know, more than half of that error from the bending has been taken out. I'm going to flip it over and I'm going to see if I can't actually kind of like preload it a little bit and take the rest of that error out when I weld the other side. And it should get pretty darn close to being nice and flat. And this is what I mean by the preload. So basically this is a side that would be high on the table. And so what I did is this side is actually raised it a little bit, which makes me compress this side down a little bit more. And hopefully after welding now these in there and it relaxes, it will relax back to a level, you know, a level piece, or pretty darn close to it, you know, as long as it's within, you know, a quarter to inch or something like that. That'll be pretty close, because again, we'll be able to do a little more manipulating once we start welding other parts on inside the car, but just trying to eliminate all these errors and get this thing as flat as we possibly can before we put it in the car. After all said and done, I don't know, maybe within 1/8 of an inch, it is pretty darn level. So this thing's ready to go into the car. Let's take a look at Sharky here before I weld in the roll cage final. The B pillar is totally welded in. The A pillars are tacked in pretty much, and I got to do a lot more welding. All the other tubes in here are just kind of like snapped into place, being held by tension with some straps, and then I will kind of tap them to make sure they're in the exact right place before I do some finish welding to get those things into position. So you can kind of see the position of the seat. You can see where the seat belt's going to land and all those kinds of things, the clearances underneath the seat. And I think what that does is it validates maybe some of the techniques that I was showing you for, you know, how to take dimensions. And it doesn't matter what kind of car you have, because I'm sure that I'm the only person who's building a roll cage for a 1996 Cutlass Sierra, but whatever car you have, I think that those measuring techniques are valid. And so I have 4 other video series which show other techniques on how to use BendTech, get dimensions, and then put those things into pick points to build roll cages like this. And then the other takeaway I think from this before I get to welding is just how good the BendTech software is. You know, just being able to make complex nodes like this absolutely perfect. This thing's just sitting in there, isn't even tacked in yet, and it is just a perfect junction right there. So really impressive, and it's just, you know, really a versatile system of software and hardware. You can be the guy who has the A400, the A250 like I have over there, but when I started, I was a guy with 2 angle grinders, the BendTech Pro software, and a template that I was printing off of a printer, and we were making roll cages for really awesome race trucks. So you can do it all, and you don't have to be spending a lot of money. People ask me all the time, what kind of tube notcher would you get? What do you use as a tube notcher? And I would never spend my money on a tube notcher. It would cost you less to get the BendTech software, and with that software, you can do amazing stuff like this, and I promise you, it'll be very difficult to do this as quickly as you can with any kind of a notcher. Let's go ahead and get to welding this thing in, and we'll be done with this project. Welcome to the headquarters here for NTD Racing at Lemons at High Plains Raceway, Colorado. There's Mamba over there looking beautiful. We got Joe on the grill cooking some burgers and some, actually I think he's cooking some hot dogs for breakfast or something like that. But let's take a look at the final product over here of all this stuff that we've been working on for Sharky. This thing looks pretty cool. Let's take a walk around, see how it's loaded up. This is after day 1 of racing. So the format here for the race is 2 days of racing. Yesterday I think was like 8 hours. Today's like 6 hours of racing. For those who have done Lemons before, they looked at our car and immediately said, you're a C0. Basically there's 3 classes. There's C, which is like probably the slowest, B, which is kind of fast, and A are pretty fast, and then the 0 means they didn't give us any penalty laps. But if you had a car they thought was maybe worth more than $500, then they start adding on penalty laps, and so we got 0 because they're like, you're a total piece of shit. There's some other things in here that we haven't done before. We got some fire suppression inside there. Joe plumbed in some of the nozzles, and you got some more nozzles in here which will put fire suppression on the driver and on the engine in the event obviously you catch on fire. Let's take a look at the roll cage real quick just to kind of see what we got going on. We got some padding on here. So we went through what is called tech inspection yesterday, and they basically go through and they say, you know, let's see how everything was done. And they didn't like our padding. They said, you really got to tighten that down, so we had to put a whole bunch of tape on there. But first, let me say, as far as the build of this cage, I think that it's totally valid as far as like how well BendTech performed as far as like getting everything absolutely perfect to make the welds really easy. And then also just how well I think the just the fabrication part with the Dragon, I mean, just really the roll cage went together well. I think it was also valid the techniques that I used for measuring out the roll cage, because everything landed exactly where I wanted it to land. But when we got to our tech inspection, there was a couple things that ended up being an issue with our tech inspection. And these are things that we didn't know. We always say, get a car to tech inspection, and that's where you're gonna do all of your learning. You learn as much as you can. We thought we followed exactly to the T what they wanted for our roll cage design. They said, here's a couple changes you need to have before you come back again. So if you want to do a Lemons car, then these are some of the changes that you would need to make if you're kind of making a roll cage. So first off, they said, you basically need to take the dash out. You need to get rid of the dash, or whatever you have to do, because you have to continue this A pillar all the way over here to the end. That's about another 6 inches, and then down. So that would move everything just slightly more forward. We could also probably lower these side tubes a little bit, which would make it a little bit easier to get in and out. Different than what we do in desert racing as far as how high we put the side tubes. Just things we didn't know, and now we do, so we can fix that. And then also in the back, we just basically made a straight tube going from the top of the B pillar all the way down the bottom. They needed to kick out a little bit, so they would be one going up the side here, a bend going up to the top of the B pillar, and then going out. And we kind of thought we fixed that with this little kick out of the side tubes here, but that's not the way they like it. They still let us race, but they said before you bring it to the next Lemons, you need to fix those things. So it's kind of minor. They were really, really impressed though, I think, with the build quality, because the guy was the chief safety guy for Lemons, and he said, your build quality is great, the welds are great, you just need to change a little bit of the design. I think that's pretty easy to do. And it doesn't cost that much. I think we put this roll cage in for about $200. So that's what it cost us to do that. So just not a whole lot to fix that problem. Anyway, we did race this thing yesterday, and it did amazing. We were one of the only teams that didn't have to come in for any kind of mechanicals. We're using the Milestar tires, and everyone's kind of chuckling about our Milestar tires, because I think every other car has proper race tires. We're using these Milestar sport tires, and they were amazing. They did really good. Now, we were sliding all over the place. We're the slowest car out here, but still the tires held up amazingly during the race, because you see these things. I think we have a couple of shots, hopefully I'll put those in here, of this car just sliding all over the course. Just a great team effort from the members here of NTD Racing and our sponsors all around. Today is day 2 of racing. Time to get to it.
The real rancher of the awards, the index of affluency. You know it when you see it, but this one had the numbers to back it up. The fast lap, about 3 minutes. Not even kidding. How many times have they run Lemons until now? Goose egg, none. How many times did they end up in penalty? 0, none. You can at least have some faith if you fly home from here, because this is a team made up of pilots and people who like to play in the desert. You saw it out there. It might have even passed you. It finished like 27.
I think it was 26.
26? Overall.
Being like the third slowest car overall.
Do you know how many Miatas and BMWs are under there? It's not even worth counting, just let it go. This car is the 1994 Olds Cutlass Sierra S number 1.
Don't forget the S. Sierra S. My favorite part of last night was walking through the paddock, watching one guy wrenching on tires with 2 giant crowbars while the other guy goes, "Should I set the cornhole up?" They know what they're doing. You're in the right place. Welcome to Lemons.
Thank you. Very well done, y'all. Very well done. We hope to see a lot more of you.
You know what? Racing's racing. And I would argue that spending less on a race car would make it maybe just a little bit that much more enjoyable, because you don't have to worry about all the other crap that goes with, you know, having just a lot of money into a car. So we've got, I don't know, maybe about into the car alone, literally $0, maybe $10 for the mods we did to the suspension. Literally about $200 into the roll cage for tubing and some of the plate metal and those kinds of things, since I had some of that at my shop already. But the tubing, about $200, is really pretty inexpensive. And then when you add in seats in the fire suppression, you're probably maybe looking at another $1,000 or something like that for all those parts. So we're really in it for a pretty low price. I think the highest price for this thing is just the entry fee into the 24 hours of Lemons. And so if you want to do something like that, you're talking about $2,500, you get into racing, and it's going to be a pretty awesome time. That bird really wants to be in this video. Anyway, we're going to do a lot more of this stuff. The next thing, as soon as this thing's out of my garage, we're getting our next Class 11 VW bug. This is going to be called the open source bug, and if you go to our website at ntdracing.com, you're going to see there's links there. They may not work right now, but in the future, that link is going to take you to all of the CAD files that we'll be using to build that car. You'll be able to build along with it. It's not going to cost you anything. There's going to be a bunch of affiliate links there, like we probably have in this video also, in case you want to purchase those things. It costs you nothing more, but it gives us a little bit of kickback so we can pay for stuff like Sharky here. Anyway, can't wait to see you then. Hope you will like and subscribe. Most importantly, hit that notification bell. Otherwise, there's a good chance you'll never see another one of our videos again, and we definitely want to see you next week. Take care of yourself.